Day 10 of 90. Today we are building HTTP request tools for security testing with Python's requests library. If you have ever used Burp Suite, curl, or any web testing tool, you already know how important precise HTTP control is. The requests library gives you that same control in Python, and you can automate it at scale. Let us start with the basics and work up to proxy integration and authentication bypass testing. First, the core HTTP methods. Get retrieves data, post submits data, put replaces a resource, and delete removes one. But during security testing, you do not just use get. You want to fire every method against every endpoint because developers sometimes forget to restrict methods. An endpoint that blocks get might accept delete. Here is how you build an API enumerator. You take a base URL and a word list of paths. For each path, you loop through get, post, put, delete, patch, and options. You send each request with allow_redirects set to false. This is important. If you let requests follow redirects automatically, you lose information. A 302 redirect to a login page tells you the endpoint exists but requires authentication. That is recon data. You filter out 404s and 405s and log everything else with the status code, response length, and headers. Response length differences between methods on the same endpoint can reveal interesting behavior. Now let us talk about session objects. When you test authenticated applications, you need cookies to persist between requests. Creating a new request each time means you lose your session cookies. A request's session object solves this. You create the session, set your default headers including a realistic user agent, then post your login credentials. After a successful login, every subsequent request through that session automatically includes the session cookies. You can then hit multiple target URLs and check whether you stay authenticated. If the response URL contains login in the path, you got redirected back, meaning that endpoint requires different permissions. This is how you map out access control boundaries in a web application. Set your user agent to something realistic because many WAFs block the default Python requests user agent string. Custom headers and user agent spoofing deserve their own attention. Web application firewalls often fingerprint clients based on their user agent string. You can test this systematically. Send the same request with different user agent values, the default Python 1, a Chrome user agent, a Googlebot string, curl, and an empty string. Compare the status codes and response sizes. If you see different response lengths, the server or WAF is making decisions based on that header. This tells you about their filtering logic and can reveal paths past their defenses. Beyond user agent, you can set any custom header. X-forwarded for can sometimes bypass IP-based restrictions. X-custom token headers might be required by internal APIs. The requests library makes all of this straightforward through the headers parameter. Proxy integration is essential for security work. When you route your Python traffic through Burp Suite, you can inspect and modify every request and response. Set your proxy's dictionary with HTTP and HTTPS keys pointing to localhost port 8080, which is Burp's default listener. You also need to handle SSL verification. Burp terminates TLS and resigns with its own CA certificate, so Python's default verification will reject it. You can either set verify to false, which works for testing but suppresses important warnings, or you can point verify at the path to Burp's exported CA certificate file. The second approach is cleaner for long-running assessment scripts. You should also suppress the insecure request warning from erlib 3 if you choose verify false, otherwise your console fills with warnings during large scans. Once your proxy is configured, you can send JSON payloads, custom headers, and any authentication tokens through it while watching everything in Burp's History tab. Authentication testing is a core part of web security work. The requests library supports basic auth, digest auth, and bearer tokens natively. HTTP basic auth sends base 64 encoded credentials in the authorization header. HTTP digest auth handles the challenge response flow automatically. Bearer tokens go in a custom authorization header. During an assessment, you want to try all three against protected endpoints. Sometimes an endpoint that rejects basic auth accepts a bearer token, or vice versa. This can reveal inconsistent access control implementations. You build a function that takes the URL, credentials, and an optional token, then fires all three methods and compares the status codes. Any difference in response behavior across authentication schemes is worth investigating. Finally, error handling and timeouts. Real scanning scripts hit hundreds or thousands of endpoints. Some hosts will be down, some will time out, some will throw redirect loops. You need to handle connection error for failed connections, timeout for slow hosts, HTTP error for bad status codes, and too many redirects for redirect loops. The timeout parameter accepts a tuple of two values, connect timeout and read timeout. Setting timeout to 3,10 gives you a 3-second limit to establish the connection and 10 seconds to read the response. This prevents your script from hanging on a single unresponsive host during a large scan. Combined with retry logic, you get a resilient scanner that reports errors cleanly without crashing. That wraps up day 10. Tomorrow we build on these HTTP fundamentals with more advanced patterns. See you on day 11.